Okay, welcome back. So this question's worded a little weird, but if you just take a moment and think about it, it says the graph of the function p is shown on the grid. And we have two symmetric pairs, -3, 3, and 3, 3. And then it says if our k of x is equal to x squared and p of x is equal to k of x plus n, what is the value of n? Well, this k of x, that's the parent function. Which means we're looking right here where our vertex, oops, dang it. Boy, it really went up. Okay. So, which means that we're talking about our vertex being here at 0, 0. And then the next line, 1, 2, 3, 4. Okay, so our graph would look something like this. It's an awful line, but it's going to look like something like that. When x is 1, y is going to be 1. When x is 2, y is going to be 4, so on and so on. This plus n, that's that when we talk about transformation and we talk about y is equal to a times x minus h squared plus k. This n is the k value. So we've shifted k 1, 2, 3, 4, 5, 6. So n is equal to -6. So if I were to rewrite the k of x being equal to x squared, p of x is going to be equal to x squared minus 6 because we shifted the whole graph down 6 units. And we didn't affect the values of x, we only affected the values of y. So that should help you solve that. So the answer for this question on number 14, your n is equal to -6, and you would bubble that in on your Scantron. Number 15, we'll go over that in the next video because it looks like it'll be a little bit wordy. Hello, okay, so in this episode we're going to talk about number 15. It says 2 customers went to a post office box to buy postcards and envelopes. And we can call this Y and we can call this X, or you can call P and E. Either way works. Each postcard costs the same amount and each large envelope costs the same amount. If the first customer paid $12 for 14 postcards and 5 large envelopes, and then the second customer paid $24.80 for 10 postcards and 15 large envelopes, what was the cost of dollars for each large envelope? Well, these equations are kind of already set up for you. The first customer equation is going to be 12 is equal to, again, we said this is y and this is x. So that's going to be 14y plus 5x. Oops, I'm running out of room over there, so let's do it over here. So that's going to be $12 is equal to 14y plus 5x. And then the second equation is $24.80 is equal to 10y plus 15x. Well, what we have here is a system of equations. The easiest one to work with here is the elimination method. Substitution, I think, would get really meaty. Really, since we're looking for what x is, so we're looking for what is x. Okay, I would want to eliminate the y value and solve for x. But let's see, we've got 14 and 10. There's no real common denominator between them. If I multiply 14 divided by 10, that will give me 1.4. So I could multiply the bottom by -1.4. So that should work. So 10 times 1.4 would give me 14. So yeah, let's do that. So I'm going to do negative because I want them to cancel each other out. So 24.80 times -1.4 will give me -34.72. And that's going to be -14y. Minus 15 times 1.4 will give me -21x. And I'm going to bring back down this top equation. So that's going to be 12 is equal to 14y plus 5x. Okay, so this gets eliminated. I'm just going to add these together. And negative 34.72 minus, or rather plus 12 will give me negative 22.72 is equal to negative 21 plus 5 will give me negative 16x. And negative 22.72 divided by negative 16 will give me x is equal to $1.42, which is our answer choice A. That on this one, that's really the easiest one. That's the easiest method to handle. Number 16. Okay. The water level of the river is measured each day during a 2-week period. And the graph models a linear relationship between the water of the river in feet and the number of days the water was measured. So that's going to be the water level, change in water level, divided by the change in days. Okay, so if I pick this day here, oops, this day right here is a perfect day. So that would be, let's see, 16, these are going up by, oops, I believe 4 units. Let's see, oh, 2 units. These are going, let's see, 12, 14, yeah, they're going up by 2 units. So this is 16, 17, 18. So this is going to be 18 divided by 8. 18 divided by 8 will give me a slope 2.25. Okay, so and I have a y-intercept, so my equation would be y is equal to 2.25x plus 16 is my equation. And so let's see, let's put this in our graph, 2.25x, whoops, plus 16, and I'm going to look at my table. So the y represents the water level each day. So this is 1 day is here. So in 1 day, I've gone up. So from day one, I have 16 feet. And then day 2, I would have 18.25 feet. So 16 minus 18.25. Oops. That's our difference. That's our slope. So F is false. G, the maximum water level is 19.5. And we can't really say that that's the maximum level because we're just talking about the measurement of the day. That's not, we don't have a maximum level that we've measured it. So that's false. The initial water level is 16. This is true. The water level was measured for 14 days. Let's see, think about this. We don't know that that was the total, that in the data that we're given that it was measured for 14 days, but the water level is measured longer, okay? Or does that make sense? Hopefully. So H is our answer choice, number 16. Number 17, if we notice all of our answer choices are exponential functions. So, it says there are 1,024 players in a tennis tournament. Each round, half the players are eliminated. Elimination, we can think about that as a decay. So that would be our equation, y is equal to a times 1 minus r rate to the power of t. And so that would be y is equal to our initial amount, 1,024, times 1 minus half the players, so that's going to be 0.5 t. So then that's going to give me y is equal to 1,024 times 1 minus 0.5 will give me 0.5 to the power of t, or rather in this case, x. So that's our answer choice B. I don't want this video to get too long, so I'm going to go on to the next video.